All right. Welcome to this update on the ConfirmaXL analog RF and mixed signal design system. This is the second update on the software, which is pretty mature, but it's still not quite finished yet. We're still doing some polishing, and we have a few more features to complete. Let's see. Some of the other news, I guess, is we're trying to figure out how to distribute this. So we've been working on a web page for this. It's not up yet, but we hope to have that up and going pretty soon. And then you'll be able to download the software, as well as any application notes and manuals and whatever else we come up with. Maybe some libraries, KiCad libraries, and things like that. Anyway, so if you're not familiar with what we're doing here, the idea is to build a IC design framework that emulates something that you might see from commercial vendors such as the Cadence Virtuoso platform, IC6, as well as tools from Mentor or Silvaco, companies like that. We're kind of focused on RF analog mixed signal chip design, but you can also use these tools to do like system level simulations. If that's more your cup of tea, you can use it like you do MATLAB, tools like that, Simulink. So for today, though, I thought I would focus a little bit on some of the interaction with uh, ConfirmaXL, KiCad, which is the schematic capture front end, free tool, by the way, so there's no licensing there either, and some of the layout programs that you can plug into the Confirma framework. So with that said, we'll go ahead and get going here. So what I have up is just a very simple schematic of digital gates. And so the idea is not to do something too complex. I wanted to just pick a very simple example so that it could simulate quickly during the video, and but it would still give you a feel for what we're doing, and also show how you would open up layouts cells from the tool. So just a quick little tour here. This is the KiCad schematic capture front end. So in terms of if you're a Cadence user, this would be like I guess Virtuoso. I guess they call it Composer these days. Actually, I'm not sure what they changed the name so often. It used to be called Composer. So this is your schematic capture front end. So this is where you hook up your schematic for simulation. This is our top level test bench. Now, I've mentioned this in the first video. Unlike standard KiCad out of the box, we've extended KiCad to support hierarchical symbols and uh, design flow, I guess you could say, and hierarchical libraries that you can share across projects and engineering team members. So what we have here, we have just some simple inverter gates. There's two different sizes. I guess this one's a what I would call a 1x inverter, and this one here is a 2x inverter, and they're just driven by a pulse train just to exercise those gates. And those gates, they're transistor level, and they're tied to a 1.8 volt supply. I think we're using maybe in this simulation it might be TSMC or Tower 0.18. I'm thinking I don't recall exactly. So this is the schematic. This is where you do your schematic capture, your design capture, and then over here is the Confirma XL um, design cockpit. So this would be similar to, say, Cadence ADE or the Keysight ADS tool set. So this would be where you set all your simulation settings and things like that. And this also helps is where you navigate up and down the hierarchy. So I think Cadence. So here in the analog cockpit in Confirma XL, you have the navigation in this area. I think what Cadence does in IC6, I think they put the navigation windows on the schematic. I actually prefer it this way because it leaves your schematic free and clear. So if you're working on a large schematic, it's nice to have the extra area. So I'll just pass. What I'm going to do is turns out that when I opened up Confirma XL, there was an existing design. I was working on a phase lock loop, so that was already loaded into the framework. So let me go ahead and pass over the new design, and you get this will give you a feel for how you bounce back and forth top level test benches, because you might be working on several test benches at the same time. So um, the way that happens is it's pretty easy. You simply, uh, from within your KiCad window, you just click on one of these guys up here, and you do this pass to confirm operation. So you hit generate here, and it passes the information over the cell name, the test bench name. It passes that over to confirm XL. So that's what's just happened here. So now the old design has been replaced by the new test bench name. So KGF inverter 1x, I guess I called that. And so that's what's shown up here. And so when it did that, also Confirma does a search of the schematic and it looks for the hierarchical symbols, these guys here, and then it figures out the hierarchy. So it lists all the hierarchical symbols that it's found. So each one of these symbols has a test sheet underneath. So I think I showed some of this in the first video, but just to refresh a little bit. So I've selected this 1x inverter, and if you want to open that schematic, you just pop down here and you say view schematic, and it opens right up. So that's how you navigate basically up and down the hierarchy. So you can see in this inverter here, um, just a very simple CMOS inverter. Looks like we have a channel length of 2 and a width of 6, one finger here, and it looks like it's doubled up here for the PMOS. So anyway, so that's the inverter cell. So um, let's see. So let's just see. Let's just look real quick here. Let me just open up the simulation settings. So there's an existing set of simulations, I believe, already set up. So I've just opened that file up. And so I believe it should be all set to simulate. But before I do that, I'm going to click on the Spice Circuit Netlist tab here. So this is the Spice netlist that was previously extracted from this top level test bench. But I'm going to go ahead just to be safe here, and I'm going to re-netlist that since I'm not sure how. Okay, so that flashed there. It just did a hierarchical re-netlist of this system, this multi-schematic, multi-level system. So that looks okay. Let's just check our simulator, which one we're going to simulate to. I've got it set to simulate to Topspice. But so here's one of the cool things I think about ConfirmaXL is you can plug in a variety of Spice simulators, basically whatever you want to use. Some might be free, like like Xyce or NGspice, LTspice. Some might be paid. Some might be fast simulators, like AFS. I think that's a Mentor tool, Siemens now, I guess, or SmartSpice. They have some pretty good Simulator Xyce is one I'm familiar with and used quite a lot in the past. And one of my favorites, though, is Topspice. It's a modest cost. It works very well. I've benchmarked it against other simulators, including Spectre. It works very well. I like that one quite a lot. Okay, so at any rate, I've got Topspice as the selected simulator, and I'm going to go ahead and say simulate. So simulate the netlist. So Topspice is opening up the Foundry models. Okay, it's just completed the simulation. I had a transient simulation set up for this. So let's go ahead and look at the plots. So just like you can plug in a variety of different Spice simulators. You can also plug in a variety of different plotting tools. And so I happen to have Top View plugged in here. Now, Top View is very interesting in that it can open up uh, output data from a lot of different simulators. So even the Top View demo. So I have I paid for Topspice. I have the full suite of Penzer tools. Um, in this case, though, I just have the Top View demo plugged in, and I did that because I was curious as to what the Top View demo tool could actually do, and I found that Top View demo will open up um, NGspice and Xyce, so long as you have things set up quite right. So you can, if you want to try Confirma initially, and you want to try it with NGspice and Xyce and all that, download the Top View demo software and plug in the Topspice demo, and plug in the Top View waveform viewer, and you'll get pretty far. You'll get pretty far using the uh, Top View plotting tool with free Xyce and free NGspice. That'll get you surprisingly far. So I just pass along that tip there. So let me see here. What did I want to plot? I wanted to plot, oh, excuse me there, I didn't want to do that. I just checking my output waveforms. Out 1A, out 1B. I'm going to plot those two. Out 1A, and I'm going to out 1B. I'm going to add those, and I'm going to plot them. Okay, so let me go ahead and I'm going to move those traces around a little bit. So let's see, move, delete. I'm going to move B on, I'm going to cut, I'm going to put it on its own plot so we could see it a little bit easier. Okay, so this is the output of the 1x driving the 2x. At the speed we're driving it at, you can see the 1x device is struggling to drive that 2x at the switching rate that we're doing. And they were pretty long channel devices, so this isn't really so surprising. So it's kind of expected. Okay, so first things first. So we did the simulation just to check that the test bench was set up correctly. But here's what we're going to do next. I'm going to go ahead and go back to the sheet navigator, and I'm going to select this 1x device, and I'm going to say we're going to take a look at the layout cell. So um, we're going to do view layout here. So we've added some buttons as we port this tool over from the pre-existing version. We've added these buttons to allow us to open up layouts in the layout tool. So we're going to say view layout. And for layout, we happen to have the lazy tool plugged in. So, oh, actually, it looks like I had K layout plugged in. So just like you can plug in, just like you can plug in different Spice simulators, different waveform viewers, you can also plug in different layout tools. So when you think about it, um, when you consider tools like Cadence Virtuoso, you have schematic capture. They have schematic capture point tool. They have waveform viewer point tool. They have uh, Virtuoso layout, essentially another point tool, and then all that is knitted together in a framework, their ADE framework. So the Cadence system is, you can think of it as an integration of point tools. Now, and I forgot to mention the simulators too. So simulator is another point tool. So you can think of the Cadence Virtuoso platform, it's a framework where Cadence has knitted together a variety of point tools. They've done a good job on it. But essentially they're point tools knitted together. They just happen to be all Cadence point tools. So what we've done with ConfirmaXL is we've taken a similar approach. So um, to put together a framework like this, it's a major task. It's a corporate level task essentially. But what we have done is we've leveraged the work of a lot of different groups throughout the world to knit together a design flow that's similar in look and feel to Cadence Virtuoso. So something that will be familiar to experienced analog designers. So if you're coming from Cadence, this will look familiar to you. If you start with this, you're a student or something, and then you eventually wind up to Cadence at some company, the transition will also, the look and feel will be very similar in that direction. So in our case, though, we're using free KiCad, powerful tool. It's very popular with PCB designers. It's been in development for 25 years. It's gotten to be very good. I like using it quite a lot. And then the same thing with on the simulator side. You've got groups from various parts of the world who've done an excellent job with the Spice simulators. Sandia National Labs, Xyce free simulator, it works very well. NGspice, I've started to use that more recently, and I like that. Qspice, I use Qspice a little bit. There's some netlist compatibility issues that I'm working to resolve in the libraries that we have here, but I'm pretty confident we can plug in. Well, we will be able to plug in Qspice without without major issues. And then on the layout side, I've shown K layout here, but if you want to plug in some other layout tool, you can do that as well. As a matter of fact, I'm going to just quickly switch the layout tool. So I'm going to go set up layout tool, and I'm going to switch the layout tool plugin from K layout to lazy, because I've used that one quite a lot as well. Then we're going to go back to the navigation portion of this, and maybe we'll try and open up this one, this inverter to 2x device. So so we've switched the layout tool. Now I'm going to open up the layout, and hopefully this will come up in lazy. Okay, it looks like it's starting. Okay, inverter 2, that looks right. And there's the inverter 2x cell that was opened up in lazy. So here we have two different layout tools that were plugged into the framework. Um, different layout point tools. We haven't changed. When you think about it, though, the flow itself doesn't really change much. So if you're coming from a background where you've got experience in lazy, you can use the tool that way. If you're coming from a background where you have a lot of K layout knowledge, you can plug in that tool. You can plug in tools like Glade if you wish. You can you can make connections as well to uh, very high-end tools like Calibre, like Mentor Calibre. In fact, that's how we use this tool at a previous company. So in that case, we did the layout. I think we used Ledit. We did the layouts in Ledit and did the DRC and LVS, all that in Calibre, and the LPE. The LPE, the layout parasitic extraction, we did that in Calibre too. So that was simply another plugin to this ConfirmaXL framework. So, okay, so I'm going to just pop these down for a moment. And so what I wanted to show next is, okay, so we have this digital top-level test bench. We have underlying transistor level cells. We've done the simulation. from the schematic view. So now what I want to do is I want to show you how you would handle like layout parasitic extraction simulations. So that's very important for IC designs, whether you're doing digital, whether you're doing analog, whether you're doing RF. So let me show you how that works exactly. So we have this multi-tab interface up here. I had talked about the include tab. We're not doing anything in this example, but in the first video, I talked about this a little bit. This is the Spice netlist, schematic view of the netlist, starting from the top level test bench. And you can see it has underlying subcircuits if you're familiar with Spice syntax. So there's an inverter 1x subcircuit here, inverter 2x was down here. There we go. So I think what I'm going to do is I'm going to do a LPE simulation. So the way that works is you go over here to the LPE tab and you open up this LPE netlist generator tool. So you open that up and you search the schematic level netlist and you find these guys. You find all the uh, all the hierarchical transistor level cells that it found on the test bench. They are presented to the designer here. This is you could think of this as being similar to the Cadence hierarchy editor. So where you do view switching. So I'm going to go ahead and I'm going to just what we're going to do is we're going to replace the schematic Spice netlist here. We're going to replace it by the LPE layout parasite extracted view Spice netlist. So we're going to pop that over there, and then down here we're going to say create LPE netlist. Now before I do that, I got to just turn this guy off. That's a detail I'll talk about on another day. So I'm going to say create LPE netlist, and if you were paying attention there, you could see that the LPE netlist tab has been refreshed. So let's take a look here. So we're replacing the inverter one subcircuit. We're replacing that. Let's look at Spice netlist. Inverter one subcircuit. That's this guy here. So you can see the Spice syntax. You have the transistors. So we're replacing that portion of the netlist with this. So now it's commented out that previous portion of the netlist and it has added this include pointer. And so this include pointer is to a Spice netlist file, which contains the extracted view. So um, it has parasitic C's and parasitic R's that came from the netlist. So whatever layout tool that you have, that's usually where the extraction is done. So if you have K layout, they have extraction tools. That tool would create this netlist, and you would place that netlist in a particular folder, and that folder is pointed to within the ConfirmaXL, if you can follow that. Similarly with Lazy, Lazy also has an extraction capability, as does Calibre. So that's how we often used it. We had Calibre for a while. So Calibre would do the LPE extraction, and then we'd place those extracted netlists in a known folder location. And then when we wanted to do the extracted simulations, this is essentially how we would do it. So, okay, so let me close that. Now, so you have this new netlist that now has extracted view uh, subcircuits in it. So now what do? So we want to simulate that. And so it's a very easy process. So here's the schematic view that we just simulated that. Here's the LPE view. We want to simulate this one now. So you go over to let's see, I think it's this tab here. So here is the simulation netlist that gets sourced to the simulator. We just did the schematic view. Now we're going to do the LPE view, and we're going to, now that we've made that selection, we're going to say simulate again. Okay, there we go. Simulated quick because our example is very simple. And we're going to replot out 1A and out 1B and take a look at those waveforms. Let me clear that one. I'll put it on its own plot. There we go. Oh, that didn't quite work out. Let me move the trace. I made a mistake, I guess. Um, okay, cut to paste. Okay. Okay. So let's compare. So I'm going to put the LPE result over here, and I'm going to put the schematic view result over here. Okay, so you can see, side by side, we changed the 1X device. This guy has the layout parasitics, and you can see the difference in the rise time here. That layout capacitance really seems to have hurt the rise times and the pulse width on the positive side. So anyway, that's mainly what I wanted to show this time. Just to recap a little bit, we showed the schematic capture. We showed how you load the test bench and the information into Confirma for the first time. We showed how you select how you do the navigate the hierarchy, view the hierarchical symbols, and how you open up an underlying schematic. We showed how you select the Spice simulator from those that you happen to have plugged in. Um, we showed um, we showed how you open up the layout. So select the cell that you want and view the layout here. We showed just briefly how you switch between layout tools. So um, okay, I think that pretty much wraps it up for this time. Thanks for sitting in. I went a little longer than I had hoped. Maybe next time I'll show something involving maybe like phase lock loops or something. There's a lot of things you can do in RF and microwave. We've extended our Spice libraries so that they can include transmission lines, microstrips, coupled modeled lines. So also S parameter based design. So maybe I'll show some examples of that next time. Anyway, so we're moving ahead. It's a bit of a process, always takes a little longer than you think, but it's working pretty well. I'm pretty happy with the way things are going. And then the website, how we're going to distribute this. And by the way, the intent here is to make it either completely free or very, very low cost. That's the idea. So okay, well, thanks for joining me, and hopefully we'll see you again. All right, thank you. Thanks for sitting in. Bye bye.